आज तुम अपना फर्स्ट एआई मॉडल बनाओगे जो रियल बिजनेस पैसा सेव करेगा. Seriously, your past 4 days of relentless hard work are finally going to pay off today. We are leveling up in a massive, massive way. So take a deep breath, get comfortable, because by the end of this explainer, you aren't just getting theory. You're going to see a complete, functioning machine learning pipeline in action. Let's get into it.
Look, let me be perfectly clear right out of the gate. Today is absolutely not a toy project. We are stepping completely away from the boring academic math and stepping directly into the real world. Because, real engineers don't just write code for fun, they solve actual business problems that save money, and that is exactly the mindset we are adopting right now. So, here's our game plan for today. 1. The dog versus cat story. 2. The magic of logistic regression. 3. The complete build flow. 4. Metrics and results. And finally, 5. Business thinking and common mistakes.
All right, starting off with part 1, machine learning and the dog versus cat story.
So what actually is machine learning when you get right down to it? Well, imagine you're teaching a little toddler the difference between a dog and a cat. You show them, say, 1,000 photos. For dogs, you point and say, look, floppy ears, bigger size. For cats, you say, pointed ears, smaller, right? Their brain naturally extracts those little patterns over time. And here's the magic part. Show that kid a brand new photo they've never seen before, and they instantly shout, "That's a dog!" all because they recognize the underlying pattern.
And honestly, this maps perfectly to professional machine learning. When the child looks at those initial photos to learn, that's what we call model training. Showing them a brand new photo, that's feeding it a new data point. And when they confidently make their guess, that is the model's prediction. Literally all we're doing is using data to teach a computer how to recognize patterns, exactly like that toddler. Okay, moving right along to section 2, the magic of logistic regression.
Now, please don't let the word regression scare you off here. Logistic regression is actually an incredibly powerful algorithm used for classification. Basically, it uses this nice S-shaped curve, which we call a sigmoid function, to calculate probability. It asks questions like, is there an 80% chance this photo is a dog? Or is there a 90% chance this customer will click on our ad? It uses probability to draw a literal line in the sand, a decision boundary that says, yep, mathematically, this belongs in category A and definitely not category B.
Which brings us to section 3, the complete model build flow.
Listen, this right here is the exact sequence used by real engineers at top tech companies. Step 1, the train/test split. This is where you divide your data into a study guide and a final exam. Step 2 is scaling. You got to normalize your values so the really big numbers don't just completely overpower the small ones. Step 3 is training. We feed that study guide into our algorithm so it can learn. And finally, step 4 is prediction. We hand it the final exam and see what it guesses. But how do we actually know if those guesses are any good?
Let's figure that out in section 4, metrics and real results.
Okay, pay close attention, because this illustrates the biggest trap in all of data science, relying solely on accuracy. When we evaluate a model, we plot our results on something called a confusion matrix, which gives us 2 super important metrics, precision and recall. Think about Netflix for a second. High precision means when they recommend a movie, you will absolutely love it, but they might miss a lot of other good ones. High recall means they capture literally every movie you might possibly like, but you're going to get a bunch of junk recommendations in there too. Finding the perfect balance between precision and recall for your specific business, that is where the real money is made.
So, look at the performance of the model we just ran. Boom, 99.3% AUC, alongside an absolutely incredible 100% recall score. That is a massive dopamine hit, right? Seeing numbers like that, you probably feel like an absolute genius on day 5. But let me ask you something. When you see a 99.3% score out in the real world, is that a reason to celebrate? Or is it highly, highly suspicious?
Let's dive into that in our final section, business thinking and common mistakes.
See, this is the exact moment we pivot from being a junior coder to a senior engineer, because perfect numbers almost always hide a massive amateur mistake. Notice that first row. Using fit_transform on your test data, that causes something called data leakage. You are literally handing the algorithm the answer key to the final exam while it's still studying. Your model just cheated. And look at row 2, assuming the default 0.5 probability threshold is the right way to go. If you are predicting cancer, you don't wait for a 50% probability threshold to act. You catch it at 10%. Business logic absolutely always overrules default code. Context is everything.
And honestly, if you just understood why data leakage is a total disaster and why tuning your threshold is vital,
You are already miles ahead of the pack. Seriously, you just mentally built, evaluated, and debugged a professional machine learning pipeline. 95% of people who start learning AI never, ever make it this far. But you did. You should be incredibly proud of that.
But before I let you go, I've got a quick mini challenge for you to lock this all in. Number 1, what is data leakage? Number 2, why is basic accuracy a trap? And number 3, why do you have to tune the threshold based on the business? Answer those in your head right now, or drop them down in the comments, and you are 100% ready to unlock Day 6. Keep this incredible momentum going, and I will see you in the next explainer.